Paul Murphy with DataCore. So good morning, good evening, and good afternoon to everybody on the line. I know we have people joining from all over the world, so very much appreciate you guys taking some time to spend with us today. We're going to get right to it. We'll be in and out here in about 25 minutes. I think we've got some great content for the audience today, all around this topic of software-defined storage and why we're hearing so much about it all over the press and from some of the major manufacturers out there today. The way I always like to start this conversation is looking at the rate at which data is growing. And most of the IT professionals that I work with and talk to have a very short time frame in what they're looking at in terms of data storage, like 1, 2, maybe 3 years. But when I really talk to people about how are we going to manage all this data 5 years and 10 years and maybe 15 years from now, the whole thing becomes daunting. Most businesses now are experiencing data growth rates upwards of 30 to 75% even in some cases. The challenges associated with data storage haven't changed at all. I mean, it's kind of been the same problems we've been dealing with for the last 15 or 20 years. They revolve around performance, cost, and management. These are the same headaches we've been dealing with over time. The way those look today, I mean, our applications are starting to require more performance. And when new things come up and new projects come up, desktop virtualization is a big one we hear about today. We increase these types of bottlenecks and things that we got to deal with to increase the performance of our data storage. And a lot of the things that we do to try and increase our performance end up making our data storage much, much more expensive. You know, the big trend today is obviously taking advantage of new hardware that's out there like flash and SSDs. And this increases our cost. And then maintaining different types of hardware and going through refresh cycles across different types of things gets very, very complicated and very costly. And now we find ourselves in a position where we've got a lot of different devices from different manufacturers that don't work together, and trying to find ways to break out of a single vendor system or trying to find ways to plan downtime starts just to get impossible. Some of these challenges just get absolutely daunting. Now, the core response to this from all of the major storage manufacturers is the same as it's been for the last 15 to 20 years. We've got a new box. This is the device that's going to solve all your problems. This new piece of hardware is going to make things work. And now just this year, in the last 12 months, we're hearing a different story. So NetApp and EMC and VMware and now even IBM have all announced their software-defined storage strategies over the last year. And that's what we want to talk about today, just a little bit about software-defined storage and why we're hearing so much of this, why the approach to our data storage problems is now starting to change. So just back off for a second, and let's just kind of take a high-level view of this, of why are people talking about software-defined storage? And the answer, we've thought a lot about this, I think is very simple. So theoretically, software should be able to do some really important things for storage if we had the technology. The first thing software should clearly be able to do for us is it should enable different storage devices to communicate with one another. So different devices from different manufacturers, there's no reason that all of the powerful and expensive hardware that we've purchased over the last 5, 10, and 15 years can't coexist and work well together. The second thing that software should be able to do, it should be able to separate advances in software from advances in hardware. Many times we end up going through storage refresh cycles just so we can get the latest and greatest software. And many times we want to take advantage of new hardware, but we're limited by the fact that we don't have software to support it. You know, we don't do this with PCs. We don't do this with servers. You don't throw away your laptop when you want to upgrade your operating system. It just seems odd that, you know, kind of at a high level, we end up doing that in many cases with storage. The third reason software-defined storage is becoming very important today is software should really be able to pool all of our storage capacity and provide a way to manage it in a centralized pane of glass. Even if we have new technologies and new types of devices, ultimately what we're doing is storing data. So there should be some way to create a piece of software that allows us to manage all of the hardware and manage it and pool it all together from one centralized place. And the final thing that's important here around what software should be able to do for storage is the stuff that's really difficult for us, right? The kind of things that are just a pain, like hardware maintenance, data migrations, hardware refreshes. Software should be able to make that stuff easy for us. This is the type of stuff that DataCore has been thinking about for the last 15 years. In fact, I've got a quote in here from our CEO in 1998. committed to creating an enduring and dynamic software-driven storage architecture. So we got a bit of experience in working on this, and most of what I want to do today is to kind of talk to you about where we've come to in terms of this whole software-driven storage architecture, or I guess the latest word for it is software-defined storage architecture. Just real quick, 2 seconds about DataCore in case you're not familiar with who we are. So we have over 25,000 deployments worldwide. Our product is currently on its 9th generation with a 10th generation coming up quickly here. So a bit about the solution. Like I said, we've been working on this technology for the last 10 years, a software-driven approach to storage management. What DataCore solution is, it's a software solution that runs on any x86 server. It sits in the data path between your application servers and any underlying storage hardware. So your flash, your SAN, your NAS, any manufacturer, your EMC, IBM, your NetApp. The DataCore solution operates in a minimum of a 2-node configuration. So they work together. There's no single point of failure in this. So again, just to make sure we're clear on kind of what the solution is and where it sits, again, runs on any x86 server. It's a software-only solution that sits in between your application servers and any underlying existing storage hardware. And by the way, I know what you're thinking, because I get this question a lot, which is, why would I want to put anything in the data path between my applications and my storage hardware? That sounds like it's going to slow things down. In fact, DataCore does quite the opposite. On average, our customers end up getting 3 to 5 times the performance out of their existing storage hardware by moving to this type of architecture. In a minute, I'm going to show you how. Core benefits around doing this, like I said, 3 to 5x performance increase, up to 3 times capacity utilization, and prevention of all planned and unplanned downtime. So here's a little bit how we get there. And this is what a 15-year in development, 9th generation software-defined storage product looks like. Back in the day when EMC and NetApp were creating their modern storage architectures, DataCore was doing the exact same thing. So it's a complete set of storage services. Some of this is similar to what you would see from an enterprise-grade hardware manufacturer, things like thin provisioning and snapshots, data migrations, disk pooling. And the thing about DataCore is that we've been developing this technology in a completely hardware-agnostic format. So this is standalone storage services that work with any types of hardware. Now, like I said, some of the things we do are typical in what you'd see in an enterprise-caliber storage system. The fact that we are hardware agnostic and we're able to pool different types of storage devices puts us in a position, a unique position, to do some things that no other manufacturers can do. So we don't have time today because I don't want to burn up your whole day to talk through each one of these things, though they're very interesting in how they work. What I wanted to do is just highlight some of the things that are possible with a mature software-defined storage solution. So there's a couple things that we'll talk about in our time together today. I want to go through how we can automatically tier shared storage resources. I want to talk to you about how we get that 3 to 5 times performance increase on whatever existing storage that you have. And we want to talk about how we can prevent planned and unplanned downtime. And ultimately, what most of our CEOs and CFOs are looking for, how we can protect our investments and lower our costs long term. So again, these are the 4 things we'll cover. I'm going to jump right into the first one, which is being able to automatically tier your storage resources. The DataCore software-defined solution allows you to create up to 15 tiers of storage within your environment. So a good example would be your tier 0, which most of our customers use flash or SSDs for. That's sort of your fastest, highest performance storage, and in many cases your most expensive. And then a second tier might be your tier 1, sort of your enterprise-grade spinning disk systems. And then maybe you have tier 2, where you have a NAS or sort of a nearline type system. All the way down to 15, the last in many cases being the cloud. What DataCore does for these tiers of storage, it's going to automatically migrate your data in production between performance tiers. So if all of a sudden one of your application servers lights up and it needs more performance, the blocks of data associated with that application that are in high demand will automatically move up a tier. So if they become in more demand on average than the tier that they're on, they're going to move up to the next one. If they decrease and they start to cool down, we'll again automatically tune real-time in production down to the tier that's optimized for the level of storage that they need to be on. So this isn't something that we can do ourselves. Most of the customers we work with, you sort of try and do this, and you do it at the application level. But this is real-time tuning. This isn't happening once a week. It's not happening every night. This is happening constantly in your environment in production. And we don't get in the way of your applications. So we only do this when there's time and bandwidth to get the data moved. We're not going to slow an application down just trying to put blocks of data up onto another tier. The financial impact of this actually comes in our ability to optimize the amount of high-performance storage that we buy. So I'll give you an example of, say you're working with a database. It may be 15 terabytes. And sort of the old way of doing business, you look at that database and you're like, this thing needs high performance. The business is asking me for top-tier performance for my database. When we all kind of know, I guess theoretically, that not all of the blocks of data associated with a single application are in high demand. In fact, even your production level database, on average, like 60, 70% of that data is near dormant. It's not even being touched. Yet, without any intelligent tools behind this, you're basically forced to buy high-end storage for all of the data associated with a single application. With DataCore's auto-tiering technology, because of the fact this happens automatically and it happens at the block level, you're actually able to take that single database and divide out, hey, what blocks of data really need the high-performance storage, and what blocks of data can I continue to store on spinning disk, while ensuring that the business who's asking me for top performance is getting what they need. So in this case, you got a 15 terabyte database. Instead of buying 15 terabytes of flash, you end up buying 5 terabytes of flash and only 10 and you leave the rest on 10 terabytes of disk. This stuff isn't cheap. We know this. You look at the cost, figure an average of $10,000 per terabyte. You're going to get $100,000 in saving by being able to optimize your investments in high-performance storage. And again, this is happening real time. This is something that's now just automatic. So when you need to add performance, all you're looking at is, hey, how full is my tier 0? If it's full, you know you need to add more, because we're only moving data up when it's in need. So you never end up buying more high-end storage than you need to. Remember I said there was 4 things we're going to talk about? That was the first, all around automatic tiering. The second thing is kind of DataCore's secret sauce. This is stuff that we've been working on for the last 15 years and are constantly improving on, which is our caching technology. So remember we talked about where this sits in the architecture. We sit in between application servers and any underlying storage hardware. We run on any sort of x86 server or 64 server. What we end up doing is turning these servers into mega caches. So we pump these things full of cheap electronic memory, and electronic memory is significantly faster than flash. It just is. That's the physics behind it. So the more we can run your applications out of that electronic memory, the faster your applications are going to go. So we do all the cute bells and whistles that you can imagine, and again have spent years and years developing the algorithms behind this. But we do all the tricks, right? We intelligently anticipate reads, so we sort of know what you're going to ask for next. And when we bring up the blocks of data, we're smart about it. We're like, okay, you're asking for this data, now let's bring up the blocks around it because we're pretty sure you're going to ask for those next. And then when it does come down to writing those down to disk, we're not throwing random writes down on the spinning disk. We take the time, keep it in memory, and we sequentially write them down to disk, so we're not throwing random writes. So we're able to get it down onto disk as absolutely fast as possible. But the ultimate thing that's happening here is that we're working to run your applications for as long as possible out of electronic memory before it goes down to flash or before it goes down to spinning disk. Remember in the beginning we talked about 3 to 5 times performance increase. That's an average. We have DataCore customers that are getting 10 and 20 times performance increase out of the existing storage that they have in their environment today by putting an intelligent piece of software-defined storage in between their application servers and their underlying storage hardware. All right, so the next thing I wanted to cover is around mirroring and ultimately preventing downtime, because downtime is not fun, and we all know that. So prevention of both planned and unplanned downtime is critical. This, by the way, also I think helps us understand what a software-defined storage architecture can do for us. DataCore allows you to synchronously mirror between unlike storage systems. So I can have a live active mirror between my EMC and my NetApp, or between my IBM and my HP. And I'm easily able to now replicate, fail over, and fail back between unlike platforms. So they don't have to be the same make, they don't have to be the same model. I now have a piece of software that allows me to run the storage services that I need to prevent downtime, regardless of what manufacturer I bought it from or what model of equipment I have. Now, When we look at this type of architecture, I think the other thing that seems clear is that it becomes very easy for us to migrate data between unlike systems, which really starts to speak to and get rid of this whole concept of planned downtime. So when I need to take a system down, I want to do some maintenance on it. I want to move it across the room, just simple stuff. I mean, we all know how difficult it is. It's like once you plug a storage system in your data center, you can never take it down. And it tends to be quite a nightmare. But now I have something in place where I can actually migrate data off of that platform while in production with zero downtime whatsoever, take the system down, reboot it, do my maintenance to it, move it across the room, and then I can bring it back up. And this is when I get to get my golf game back on the weekends, right? I'm not coming in on Friday trying to do the big data migration all weekend. I just have a software architecture in place that allows me to be nimble. You know, this reminds me of 10 years ago when VMware first came out, of this concept of vMotion was like kind of this black magic type thing, where DataCore customers typically like, wow, I just didn't understand that those headaches that I had around data migration could easily go away. The other final comment I want to make on this mirroring concept is just this whole idea of metro-wide synchronous mirroring. So being able to put data centers up to 70 kilometers apart, about what, 40 miles, 45 miles, I think, that are synchronously mirrored between storage systems of any make or model. So now I can actually have multiple data centers with different types of storage hardware that are running in active configurations. In fact, we had a customer down in New Jersey who was hit by Hurricane Sandy, and they literally had a pool of water in their data center. They're running a hospital, but they had zero downtime whatsoever. They're in the middle of a hurricane, so they're hunkered down in their houses, but ultimately the DataCore solution, it's not like it fails over. This is active. The two data centers are running on one another. So no one had to pull the trigger, go to the data center to get it to fail, because you're not going to go outside during a hurricane. But they actually had zero downtime whatsoever to all of their hospitals in the local area, which were obviously critical during Sandy, without even having to touch it. The net result on this, once we have something in place that allows us to do things like mirroring, replication, both synchronous and asynchronous, and data migrations between unlike platforms, the time that we spend on data migrations, hardware refreshes, capacity expansion, hardware maintenance, and unexpected downtime decreases significantly. Surveyed DataCore customers report spending nearly 2/3 of their time on routine storage tasks. And again, these are the things that we talked about in the beginning, the stuff that's just tough for us, the things around storage management that are just a pain. Decreasing that from almost 2/3 of their time to less than 1/4 of their time now that they have a single storage platform for all of their hardware. Like I said, there's only real 4 points we want to make today. We want to make sure we get you guys out of here on time. But the final thing, and I think which is most important here, is this whole concept around investment protection. Having a single storage platform for all of your storage hardware now breaks you out of this sort of, am I locked into a single vendor? Am I worried about managing different types of systems? And do I have to always buy the most expensive hardware? In many cases, DataCore customers now start looking at, hey, I have something, a high-performance caching tool that allows me to get increased performance out of whatever I have. I already have all of the replication software that I need. And I'm also able to automatically tier, so I don't have to buy significant amounts of very high-performance storage. So I sort of break out of this lock-in that I have to a specific vendor or a specific type of system. Many DataCore customers start leveraging much lower cost arrays, and some even get into even white box type stuff for archival or tertiary storage. The final thing around investment protection is now really looking at, I don't know what's going to come next. You know, after Flash, say, you know, Flash hits its point of maturity, and now there's some new optical storage that comes out. I don't know what it is, but I want an architecture that allows me to easily take advantage of it. I want all the software in place, and when some new, latest, greatest hardware comes out, I want to be able to easily integrate it into my environment. All of these things combined have a significant financial impact on the way we look at and think about storage. I'll walk you through just a quick economic model of looking at hardware refresh before and after having a software-defined solution like DataCore. I'm using a large example, and don't take that out of context, because actually the economics work the same for a 2 terabyte environment as they do for 100, as they do for a 10 petabyte environment. But in this example, before DataCore, looking at 100 terabytes mirrored, or 230 terabytes raw, you'll spend upwards of $670,000 and $650,000 on hardware and software respectively. With a software-defined storage solution, remember now you have one single storage platform and you no longer have to buy all the high-end stuff. You can actually get that total cost down under $500,000, which is 62% savings. DataCore customers surveyed, they'll report up to 75% savings on long-term storage costs. And again, the drivers of this are better utilization of the hardware you have. So you get more out of the storage capacity in your environment and that you buy. You're able to leverage lower cost hardware solutions. Example is not needing to buy as much high performance storage or looking at the next model down or below that. And a decrease in licensing costs, because you're no longer buying the same software from 2 or 3 or 4 different vendors, or you're no longer buying the same software across multiple sites. So this is a very general example, and we kept it general for a purpose. You know, this is the type of thing where we really like to get in with our prospective customers, talk about what they're currently doing today, and show them how a real software-defined solution can significantly decrease their storage costs over time. So again, there's only a few things we had time to cover today. We didn't want to keep everybody here. There's a lot of different things that DataCore does. But just in summary, we talked through automatic tiering, high-speed caching, getting that 3 to 5 times performance, how we can synchronously mirror, and the idea of protecting your investments long-term with one storage platform across any type of storage hardware. And now when we go back to, hey, let's look at the challenges that we have around storage. You know, performance starts to get a lot easier. When out of the box, you're able to get 3 to 5 times the performance out of whatever storage hardware you have today. And you're able to easily integrate flash and other high-performance technologies in your environment. Your costs get to decrease significantly. So tripling the utilization of whatever storage capacity you have makes a big difference in your storage costs. And now you have a decreased dependence on any single hardware vendor. So this hardware refresh cycle that's so costly and painful now becomes something we can skip, or something you don't really have to do. And the management gets easier. I mean, we talked about being able to go from spending over 60% of your time to under 25% of your time on just routine daily storage tasks. So I guess in summary, you know, I hope we've shared some insightful information today on software-defined storage and what is possible. Again, this is stuff that we've been working on. This is basically all we think about. We're a software-only company. We provide one storage platform for everything. You know, a lot of times I get asked, hey, when should I really be thinking about software-defined storage? I mean, I hear a lot about it. And so I guess really the last thing we leave everybody with is our recommendation really be, you know, before you're making your next storage purchase, you really want to look at the software-defined storage solutions that are out there. Just see what your other options are, as opposed to continuing down this model of just buying new hardware. Anytime you're considering flash, or if you're using flash or SSDs, it's a great opportunity to look at what sort of software-defined solutions are out there, because the flash technology is great. Most of the vendors have yet to have a very mature software stack backing it up. So the majority of DataCore customers that are using flash are very happy about the fact that they get a robust software solution to perfectly accompany the new flash technology they're integrating. And of course, prior to any data migration projects, we just have lots and lots of customers who are concerned about a large data migration, who leverage DataCore, and it's almost kind of try out DataCore to help with the data migration and see what the power of a software-defined solution can do. So that wraps it up for today. We got a couple minutes for questions. Certainly appreciate everybody joining in. I'll go ahead and open the question box to see what we have. You can type any questions that you might have in the questions box in the chat window there. All right, so we have one question from Jeff, and the question was, okay, so DataCore runs on any x86 server. Do they work together? What if one fails? Which is a great question. I know we showed a very general sort of network diagram of this. So Jeff, yeah, so we do run on any x86 or 64-bit server. We operate in up to 16-node configuration. So we can string 16 of these together that do work in unison and fail between one or another. There is no single point of failure between these. Okay, I have another question here from John, which was, how does this compare to VMware's vSAN technology? Which is a great question. VMware's vSAN technology is really about taking the internal direct attached storage from an application server and potentially any flash cards installed on an application server and pooling those together to create, a virtual SAN, sort of a SAN created out of direct attached storage. So for example, you'd have a string of 6 servers, you take all of their direct attached and allow them to share that between the servers. So that's sort of the direction that VMware is going with their vSAN technology. It is still in beta right now, and that's a configuration in use by many, many DataCore customers. So our software does run actually directly on application servers and allows you to do exactly that. Really the core difference right now between VMware's vSAN and DataCore technology is really just the maturity. So the ability to create a virtual SAN out of direct attached storage and have things like snapshots and replication and federation down into your actual SAN and high availability and kind of that whole picture that I showed of all the different functionality. We have that all built out today. My guess is it'll take VMware a few years before they get there. Okay, and I think we have time for one more question. I'll take this question from Thomas. So this is, how does DataCore handle remote sites or multiple data centers? It's a great question. It's a bit of a longer answer, but I'll respond to it as quick as I can. So the replication technology that we talked about, as well as all the other services that DataCore provides, we can operate synchronously across a metro-wide area, which is about 70 kilometers, and then asynchronously across basically any distance, just solely limited on the wire. And both of those technologies have been in place for the better part of 5-10 years now at DataCore. So most of these are on their 6th or 7th generation. And so we have very elegant ways of handling multiple sites and multiple data centers. The whole concept of business continuity becomes very easy and very palatable when you're able to have 2 data centers in a metro area that have different types of hardware, different makes, different models, potentially different manufacturers, but they operate in an active configuration because they're all governed by a single software platform. And it's really the same story for remote sites. Many of our customers look at, especially when they have satellite offices that don't have a significant storage requirement, but do have the same availability requirements. It becomes very easy then to use this virtual SAN type technology where they can leverage the internal direct attached storage from servers and create a virtual SAN out of those, and then replicate back to either a DR site or the central data centers. The same thing works for low-cost hardware. So you can buy sort of a cheap NAS or a low-cost SAN type device in each location and just have a single piece of software that allows you to manage that remotely. So listen, that's the last question we'll take today. If anybody did have any questions that were submitted in the chat, we're going to go ahead and respond to you via email. But again, very much appreciate everybody's time today, and I hope this was educational. Let us know if there are any other questions we can answer for you. So thank you for your time, and cheers.